Hello, everyone. Today, we want to interpret free body diagrams and also to amplify your understanding about free body diagrams. Now, to do this, we need to consider Newton's laws of motion. For the first law, it states that a force is needed to cause or change motion. This is also called the law of inertia. For the second law, it states that force equals to the rate of change of momentum, which equals to the expression of force equals to mass times acceleration, or force equals to mass times velocity, which is momentum divided by time. For the third law, it states that for every force, there is an equal but opposite force. In summary, for every action, there's an equal but opposite reaction. All right, now let's consider having an object. For this object, it will have a weight. And since it has a weight, the weight is acting downwards under the influence of gravity. Therefore, it is given as mass times gravity. So weight is a force. Based on the third law, there must be an equal but opposite force acting upwards, and this is called the normal. If we should apply a force going towards the right, then there must be an equal and opposite force acting towards the left, and this is called frictional force. Now let's put this into perspective. Now let's say we have three forces, A, B, and C, and what we're going to do here is to interpret these forces in terms of X and Y components and also the net force in these components. So for force A acting towards the left, then for the X component, the value must be negative. There will be no Y component since it is not an angle. There is no angle at all. For force B acting towards the right, then the X component must be positive. There is no Y component because it is not acting at an angle. For force C acting downwards, then there's no X component because it is not at an angle. The Y component must be given as a negative value of that force. Now, the net force of the X component must be expressed as the negative value of A plus that of B, and B is positive. If you choose, you could add C to it, which is 0, which is really not making any difference. For the net force in the Y component is expressed in terms of a negative value of C because A and B, they are 0. Now let's look at another example using three forces, 4 newtons, 7 newtons, and 3 newtons. If you notice the 4 newtons and the 7 newtons, they're acting at an angle. So therefore means that if we should calculate the X component of the 4 Newton force acting towards the left at an angle, then the expression is the negative value of 4 cos theta. For the Y component acting upwards, then it must be given as 4 sine theta. For the 7 Newton, the X component at an angle, so it is expressed 7 cos theta, and it is a positive value because it is going towards the right. For the Y component acting upwards, then it must be expressed as 7 sine theta. For the 3 Newton force, in the X component, there's no X component at this time because it is not acting at an angle. For the Y component, it is the negative value of that force, which is negative 3 newtons. The net force in the X component is expressed as the negative value of cos multiplied by 4 plus that of 7 cos theta. All right, and so again, you do not need to put the 0 there, no need, really waste of time. And for the Y component, it is expressed as 4 sine theta plus 7 sine theta plus negative 3. All right, now let's make a change in this diagram. And the only thing we're going to change at this time is the 3 newtons, and the 3 newtons now act at an angle. So we're going to analyze the 3 Newton part. The 4 and the 7, they are just the same as before. Now, what I want to point out, a matter of fact, I'm going to start with the y component. And so the y component of the 3 Newton will be going downwards. And so it must be at an angle. And so here now, the value of this, and I want to make a note of this. If you notice that the x component, they were in cost, but because this line, which is the y component, is adjacent to this angle, then we have to put here for cost in the y component. All right? And it must be a negative value. If you remember the vector lesson, this can also be calculated using the Cartesian values or the Cartesian principle by taking the angle from the positive x in the anti-clockwise direction, and that will be sine. In that case, you also get a negative value, which is the same thing as the cos here. All right, so if you want to put an angle there and try it out, then by all means, and you'll see that it work out to be the same. Now, for the x component, which will be going towards the right in this case, which means it's a positive, and so therefore the x component must be 3 sine theta, and why sine? Because the x component is opposite to the angle. Again, if you use a Cartesian, you'll take it all the way from the positive x anti-clockwise direction, and you use a cos instead of sine. All right, and so therefore you end up with a positive value as well. All right, so the net force in the x component here is given as the expression of a negative value of 4 cos theta plus 7 cos theta plus 3 sine theta. And for the y component, it is given as 4 sine theta plus 7 sine theta plus negative value of 3 cos theta. All right, and again, please notice the sine and the cos due to the sides and the force that is here of the 3 Newton. All right, so I hope this was simple for you and hope it really amplify your understanding. And I really want to thank you for watching this lesson and also other lessons. And I want to leave you with a quote from Albert Einstein. And it states that peace cannot be kept by force. It can only be achieved by understanding. Have a safe and blessed day, and I hope to see you soon.